Hello students, I am Dr. Ramya from Basic Science and Humanities Department, working as an Associate Professor in Mathematics. So I am just before here to just deal the subject Probability and Statistics for your second year first semester. So here, Probability and Statistics might be you have learned in your schooling and intermediate level. But some extra things we will learn in the Probability and Statistics in this semester here. So, as we know that probability and statistics means if you use the term here probability, the basic example for probability is here tossing a coin. So here, this subject is applicable for you in the data mining, robotics, then modeling, reliability modeling, machine learning and all. So here you can see the picture. So how this probability and statistics is useful for your current semester. So it is useful in robotics, machine learning, data mining, reliability system and all. So here you can see that at most importance of this subject is here the traffic signals, right? Not only the traffic signals, even you can observe when one person is talking through mobile, right? So some noise will be there. So that noise also we can using probability, and we can reduce the noise also using some chapters in this probability and statistics. Then coming to the syllabus here, so the first unit is here random variables. So here just we have to define the probability, and definitely there will be some value to the experiment of that sample space here. So that value is nothing but random variables. So now here in this unit, the random variables are classified into discrete and continuous. So you will be having some properties on those random variables and the moment generating functions. Then second unit is here distributions. Definitely we have to assign some function to the random variables. So those functions are nothing but here classified as discrete and continuous functions here. So among the discrete we have a binomial and Poisson distribution in your syllabus, and among the continuous you have a normal, gamma and variable distributions. And among this normal, gamma and variable distribution, normal distribution is widely used in almost all the fields of science and technology. Then coming to the third unit, it is sampling distributions. Now the first two units we will discuss about the random experiments, but from third unit onwards we will discuss about the raw data here. So how to collect a data from the population, how to find the error, how to estimate the size of the sample here. Then fourth unit is here testing of hypothesis. Now after the collection of data and identifying the error and finding the confidence limits of the sample you have collected, then next we have to analyze the sample. So that analyzation of sample is again classified into the large sample and small sample. Then the last unit is here correlation and curve fitting. So correlation means here when we deal with a linear data of two variables, that is bivariate data here, then is a relation between the two variables exist. If at all it exists, right, can we predict the data? That can be determined using this correlation, regression and curve fitting. Okay. Now next we will go through the first unit random variables. So in this unit first we will see what are the contents in the first unit here. So the first topic is review on probability. Even though you have learned in your schooling and intermediate level, but some more things just we have to learn here. Then after the probability, then we have to discuss the definitions of random experiment, sample space and events. Then third one is random variable. Then fourth one is mathematical expectation and properties, and the last topic is here moment generating function. So before starting this contents here, first just we have to know what is the application of probability. So just we will consider an example that one student is talking through mobile, right? So here whatever he is talking is nothing but the bit of data. So that bit of data has to be transmitted through the tower. So if it has to be transmitted in the concept of 01010, right? But due to some noise, it is just transmitting in the form of 101010. Then just in order to identify the noise and to remove that noise, we will use this probability concept. That means whenever a student or any person is talking through mobile, some noise will be there. So that noise, the probable of noise can be detected using this probability concept. So that what you can see here, the transmission of data, right? Then the next one is here just before starting the random experiment sample space and all, right? So first we will discuss the basic concept on this. So whatever the experiment, suppose we consider the example of tossing a coin. So tossing a coin is nothing but performing an experiment here. So here performing an experiment is known as a trial. So for example, the basic example we consider is a tossing a coin. So trial is nothing but performing an experiment, and the example you can take it as tossing a coin. Not only tossing a coin, you can consider the example of rolling a dice also, right? But before tossing a coin itself, we know the outcomes of the experiment, means we know the results of that, head and tail, right? But we are not sure whether head will occur or tail will occur. So just if you place the results of the experiment at one place, that is called a sample space here. That is nothing but the set of all possible outcomes of a random experiment is known as sample space. And this sample space is denoted by capital S, and always we have to represent the sample space within a curly brackets. So here I have taken the example of tossing a coin again. So the sample space for tossing a coin is head and tail. And also you can take the example of rolling a dice. So the sample space for rolling a dice is here 1, 2, 3, 4, 5, 6. These are the outcomes of that rolling a die. But finally, there will be only one result of the experiment. If you consider the cricket match, right, either winning the match or losing the match. Of course, before playing the match itself, we can just say that today India will win or today Pakistan will win. But we are not sure. At the end of the match only, we can say that India has won the match or Pakistan has won the match here. Right? So like that, for every experiment there will be only final outcome of that. So here that outcome is nothing but it is from the sample space only. So the subset of a sample space is known as an event. Right? So that whatever the event we are just drawing that is nothing but chance of happening of an event, which is known as probability. And moreover here, probability lies between 0 and 1. That means the probability cannot be negative here. Right? So this probability theory is used in daily life in biological, physical, actuarial management and computer science. Everywhere we use this probability because everywhere we will have some prediction about the things happening around us. Then the next one is here, James Bernoulli has introduced this definition. Means probability is defined using three ways. The first one is that mathematical definition of probability, which is also known as classical definition of probability. It was introduced by James Bernoulli. But according to him, we can find the probability for only a fixed number of tiles. That means if I toss a coin for only 5 times or 10 times or 15 times, I can easily predict that event here. So that can be calculated using the formula P equal to M by N, where M stands for number of favorable chances and N stands for the total number of chances. But this mathematical definition of probability is applicable only when we have a fixed number of tiles. That means when we are tossing the coin for some 5 times or 10 times, and when we are rolling a die for 5 times or 6 times. But when the tossing a coin is repeated for some 15 times, 20 times or 25 times, it is highly impossible for us to calculate the happening of the event. It may take a long time, right? Then this mathematical definition is failed to calculate that. Then another statistician, von Mises, has introduced the concept statistical or empirical definition of probability. So according to him, we can find the probability when the number of trials are very large in number. Right? So might be in your intermediate you have learned the L-Hospital's rule. So using that L-Hospital's rule, the probability is given by limit n tends to infinity m by n. Again where m stands for the number of favorable chances and n stands for the total number of chances. So here when an experiment is conducted for some large number of times, suppose we toss a coin for 100 times also, then also we can find that probability here. Right? Suppose at a time in a particular interval of time, some 1000 users are using the mobile, and to detect the noise, there we can use this L-Hospital's rule, that is the statistical definition of probability. So the other name for statistical definition of probability is empirical definition of probability here. And another statistician, A.N. Kolmogorov, he introduced the probability under the following 3 conditions. So according to him, to satisfy the probability conditions, the first one is that probability of sample space must be equal to 1. So if you see the tossing a coin, the sample space for tossing a coin is head and tail. So the probability of getting head is 1 by 2. So number of favorable chance by total number of chances. Total outcomes are 2 and I am in favor of head. right? So 1 by 2 here. Similarly, probability of getting tail is also 1 by 2. So if we add this 1 by 2 plus 1 by 2, it becomes 1. If we consider the rolling a dice, right, the sample space for rolling a dice is here 1, 2, 3, 4, 5, 6. So totally 6 numbers here. So probability of getting 1 is 1 by 6, 2 is also 1 by 6, 3 is also 1 by 6, 4 is also 1 by 6, 5 is also 1 by 6, and 6 is also 1 by 6. So if we add all these 1 by 6, again it is equal to 1. So whatever may be the experiment, but finally the probability of the sample space must be equal to 1. That is the utmost condition satisfied by the probability here. Then second axiom is that probability of A is greater than 0 where A is known as arbitrary event. So what is this arbitrary event here? So while doing the chemistry practicals and physics practicals in your first year level, if you consider the example of some titrations in a chemistry lab, you have to mix up two solutions to get one particular color. So let us consider that we are mixing up two solutions to get one blue color here, right? But while mixing that, just after mixing the solutions, just we have to move that container. We have to move that container to get that particular color here. But you are not getting that exact blue color. You are getting some color which is near to blue. But anyhow, you have to get that exact blue color here. Then in that case, again we have to add some more solution to that. So whatever the color you are getting just near to blue is called the sudden occurrence of the experiment, which is an arbitrary event. So it has also some value, and again you have to add some more solution to that so that we can get the exact blue color here. So it means we are not stopping that experiment there. Again we are continuing that with adding some more solution here. So that means the sudden occurrence of the experiment has also some value, that is arbitrary event. Then the third axiom is that if A1, A2, so on An are n mutually exclusive events, then probability of A1 union A2 so on union An is equal to summation of I equal to 1 to n probability of Ai. That is probability of A1 plus probability of A2 plus probability of A3 so on probability of An here. Right? So what are these mutually exclusive events that we will going to learn in the next class?